The coldest place in the observable universe is not in deep space. It is not a distant nebula billions of light years away. It is a physics laboratory. And it is colder, by a significant margin, than anything that exists naturally anywhere we have ever observed. This is the story of absolute zero. Temperature isn't something you can touch. It's a measure of how fast particles are moving. Hot means fast. Cold means slow. Absolute zero, 0 Kelvin, or minus 273.15 degrees Celsius, is the lowest possible temperature. Particles never fully stop. Quantum physics doesn't allow that. But this is as close as nature gets. The coldest natural place we know is the Boomerang Nebula, a dying star system about 5,000 light-years away, chilled to just 1 Kelvin above absolute zero. But in a lab, humans have gone further. Aboard the International Space Station, the Cold Atom Lab has reached temperatures in the picokelvin range, roughly 10 billion times colder than the coldest natural place in the universe. In orbit, on a space station. When matter is cooled to a fraction above absolute zero, something extraordinary happens. Individual particles lose their individual identities and stop behaving like individuals. They begin to behave as one coherent quantum system. This state is called a Bose-Einstein condensate, predicted in 1924 by Albert Einstein and Satyendra Nath Bose. It wasn't created in a lab until 1995, over 70 years later, for which the researchers won the Nobel Prize. In a Bose-Einstein condensate, atoms share the same quantum state and behave like a single giant particle. In certain experiments, light passing through it slows from 300 million meters per second to just 17 meters per second, slower than a bicycle. Scientists have even effectively stopped and stored light inside it. It can also behave as a superfluid, flowing with zero viscosity. It climbs container walls, slips through impossibly small gaps, and defies everything we expect from normal matter. The rules of everyday physics no longer apply here. Creating these extreme cold environments requires extraordinary technology. Lasers that cool atoms by slowing them using photon momentum, magnetic traps that suspend atoms in a near-perfect vacuum, and precision that pushes the absolute limits of engineering. The payoff is enormous. Ultra-cold physics has enabled the most advanced atomic clocks, accurate to within 1 second in hundreds of millions of years, the foundation of technologies like GPS. It's also allowing scientists to test the deepest theories of quantum mechanics with unprecedented precision. Many quantum computers, potentially the most transformative technology of the 21st century, operate at temperatures close to absolute zero to preserve fragile quantum states. IBM's quantum processors run at around 15 millikelvin, colder than the Boomerang Nebula. The Extreme Cold Lab is not just a scientific curiosity, it is the frontier where the technologies of the next century are being built. The quest for absolute zero has revealed some of the deepest truths in physics. The third law of thermodynamics states that absolute zero is unreachable. You can approach it asymptotically, getting closer and closer, but never actually arriving. This isn't a failure of technology, it's a fundamental limit of nature. Absolute zero is not a physical destination, it's a boundary. And yet, in approaching it, we've discovered entirely new states of matter, confirmed the predictions of quantum mechanics with extraordinary precision, and built technologies that shape the modern world. The coldest place in the universe is a human laboratory. And what we've learned there helps explain the hottest, densest, and most energetic phenomena in existence. The coldest place in the universe is not the emptiest, most remote region of space. It is a room-sized laboratory built and operated by human beings who decided to push further than nature itself has gone. That is what science is. Not just understanding the universe as it is, it goes beyond it. Subscribe to Fact Lab Pro. Keep watching for more incredible science facts.